Alright guys, exponentials and logs today. Exponentials and logs today. So we're going to kind of learn a new concept. Yay! Alright, so we can see here we have an exponential equation and a logarithmic equation. These are interchangeable. These are, I would say, quote-unquote, inverses of each other. So when we can see, we have a base, and we were used to seeing this form. The base raised to the exponent equals the result, right? So in this case, let's just say we know a base of 2. 2 raised to the second power is equal to 4. Okay, that's common knowledge. We all know that. Now, we can rewrite this and mix these around using a log, right? So we're going to take the log of the base, and we're going to multiply it by our argument, or our result, and it's going to equal our exponent. So we could say that in this case, 2 squared equals 4. We could say that we're going to take the log base 2 of 4, so log base 2 of 4, and that's going to be equal to 2. Right? So we take the log of this, the log base this of 4, and it's equal to my exponent. Alright, so let's rewrite these. Okay, so I've got 4 raised to the third equals 64. Again, we all know that. So we could say that the log base 4 of 64 equals 3. Okay, let's continue with that. So let's hop down here to this one. So I've got the log base 3 of 243 equals my exponent of 5. Or I could say down here at the bottom, the log base 10, which I'm not going to write base 10, and I'll explain why in a second. The log base 10 of 10,000 is equal to 4. Now, I didn't write log base 10 because it's understood that the log is base 10 unless it's otherwise denoted. So if you don't see a base here, it's an understood 10. Okay, and it says that right here. There's no base given, it's an understood to 10. Right? So in the same respect, we say x. We don't write 1x, we say x. Right? It's the same thing. We don't say log base 10, we just say log. Okay, it's an understood 10 unless it's otherwise denoted. Alright, now let's go do, let's hop back up here if we didn't do this one. So I've got the log base 2/3 of q equals p. Now let's do the opposite, right? So I've got the log of 5, the log base 5 of 1 over 25 equals negative 2. So we'd be writing, I'll take the base 5, my exponent of negative 2, 5 raised to the negative 2, and that's equal to my result of 1 over 25. Okay, I've got 1/2 as my base. My exponent is raised to the n, and that's equal to m. Or I've got a base of 7 raised to the negative 2 is equal to 1 over 49. Or I've got 1/3 base raised to the w equals b. Last one I've got, log base 8 of 1 equals 0. Now it's important to note that the base and the argument, or the result, cannot be negative. Cannot be negative. You can only have a negative exponent. Okay? But the base, this, or this, cannot be negative. Okay, so in this case, really, it shouldn't work. It's undefined. Alright, so here we go. Let's look. Let's evaluate log base 3 of 81. So let's rewrite that in a form that we know how to do. So we're going to rewrite this in exponential form. So I'm going to take my base of 3, and we need to raise that to an x power to get my result of 81. So 3 raised to the x power equals 81, right? So I rewrote that as my exponential, just like I did right here. Right? So 3 raised to the what power equals 81 is what I just did. I took my log base this. I didn't have this. This was my x, and it equaled 81. So I need to figure out what is x here. So 3 raised to the what power equals 81. Okay, so what I'm going to do is I'm going to rewrite 81 as a base of 3. So 3 raised to the x equals 81 written as a base of 3. So 3 raised to the what power equals 81? Well, 3 raised to the 4th power equals 81. So So I just rewrote my 81 as a base of 3. Now, these are the same bases, so those cancel out, and I get x equals 4. Okay, or you could, by intuition, say 3 raised to the 4th power equals 81. Same thing, I'm going to say my log. So I've got my base of 1/3 raised to what power? X is equal to 1/27. So again, let's rewrite this as that base. So I've got 1/3 raised to the x equals 1/3 raised to the -3. Sorry, not -3, +3. Okay, so I know now the like bases here, so I can drop my base. I know that x is equal to 3. Well, that should make sense. If I take 1/3 and I cube it, I get 1/27. Alright, log of nothing here. Okay, so again, if there's nothing written there, it's an understood 10. So 10 raised to the what, x, is equal to 1/100. So again, let's rewrite it as a base of 10. So 10 raised to the x equals, this written as a base of 10 would be to the -2. So now I know the same basis here, that x is equal to -2. In this case, I have 8, the base, raised to the x equals -64. Now again, you can't take the log of a negative number. You can't take the log of a negative number. This is undefined. There's no way for me to take 8 and raise it to something and get a -64. 3 base raised to the x equals 3 raised to the 5th. Well, again, I already have like bases, so I know that x equals 5. 64 raised to the what equals 8. So rewrite this as a base of 64. So I know x equals 1/2. Right? Square root of 64 is 8. 5 raised to the what equals 5? Well, x equals 1. That's intuition. E base raised to the x equals 1. Anything raised to the 0 power is 1. So x equals 0. Alright, now we're given that f of x equals the log base 3 of x. Find f of 243, f of 1/27, and f of square root of 27. So I'm going to plug these in for x. Right, so let's rewrite this first one as the log base 3. I'm telling you it's the log base 3 of 243. So in the same respect that we were doing up here, I've got base raised to the, we don't know, is equal to 243. Okay, well let's rewrite 243 as a base of 3. So we would say 3 raised to the x equals 3 raised to the 5th. Right? 3 raised to the 5th is 243, so I've got x equals 5. Alright, I'm going to plug in 1/27 in place of my x value. So I've got log base 3 of 1/27 equals x. I need to figure out what the exponent is. So base 3 exponent x equals 1/27. So let's rewrite this as a base of 3. 3 raised to the x equals 3 raised to the -3. Right? I need a negative to get a fraction, and I need to cube the 3 to get 27, so -3. So x equals -3. And here we go, last one, log base 3 of square root of 27 equals x. So 3 raised to the x equals square root of 27. Okay, well how do I get 27 from 3, right? I cube it to get 27, but I need the square root of that. So not only am I cubing it, I'm raising it to the square root power, or the 2/3 power. So let's look at this. I've got 3 raised to the x. Well, this would be 3 raised to the 3/2 power. 3/2 power, excuse me. Because 3 cubed is 27, the square root of that. So I know that x, since I have like bases, x is equal to 3/2.